quick show of hands. Who here loves the PDX airport? All right, yeah. Oh, even some hoots and hollers there. I love it. Well, that's why it's been named America's Best Airport 6 years in a row. On track for number 7 this year. Fingers crossed. We'll see. So my name is Jesse Milan. I'm the co-founder and CTO of Megaverse Consulting. I'm also the digital communications manager and application architect for the Port of Portland. Some of you may not know, the Port of Portland owns and operates 5 industrial business parks, 4 marine terminals, and 3 airports, including PDX. We are embarking on a 5-year, $2 billion project called PDX Next to build the airport of the future. If you love PDX now, like some of you just said you did, wait till you see PDX Next. It's actually going to be really, really spectacular. Next slide. So they go really fast and then they go really slow. So I'm here to talk to you all about how we transitioned our architecture from spreadsheets into microservices to build a scalable architecture to help support the airport of the future. So first off, when I talk about microservices, what do I mean? Really, they are a loosely coupled, disparate set of data, independent of any other set of data, with some interface to access and expose that data. It's really that simple. Then they have simple protocols. We build web APIs, so they have URL GET requests or HTTP verb, and they're independent, modular, reusable, and they can be isolated, built, and deployed completely independently without impact on any other systems. Sounds good, right? So when I started at the Port of Portland, this was our website. It's very 90s. It also is not responsive, so that was fun. But you can see it has some data. It has a menu, it has some news and updates, it has some parking availability, there's weather on the page somewhere on there. So when each one of these web pages actually was backed by an individual spreadsheet. Some of you may be able to relate to that. If you zero in on a simple part of that, you take a contact. You have multiple contacts or the same contact on multiple pages. Now that contact leaves, changes their name, you have to update multiple spreadsheets. Sometimes you leave a spreadsheet open, it crashes the site. It was a nightmare. We were spending over 50% of our time fixing bugs, updating redundant code. Since each one of those spreadsheets had its own kind of basic schema, we were copying and pasting the code and then updating it. So we had to fix it. So what do? We did a full review of all of our data sets, and we built a new schema to handle that, and then we migrated the data. Then we took another review and we isolated them out into the disparate sets of data, and we built a microservice, so like a contact service. So now we can expose that data to the world, basically. So this is self-contained, completely reusable, and independent from anything else. So once you have multiple microservices, then you want to think about API management so you can manage all of those. So there's a lot of software now in AWS or Azure or like Apigee or MuleSoft provide these API management tools. And it also has a service registry, which just registers the service. So now we have the full architecture. The request process is client application, doesn't even know anything about any of the services. It just makes a request to API Gateway. API Gateway checks the service, the registry, determines if it has access to that endpoint, routes it to the correct service, gets the data, sends it back. So I don't know if you can tell from here, but now you can stand up n number of clients, and the same ecosystem will support that. You can have Internet of Things devices, mobile apps, partner applications consuming your data, and it's completely independent and agnostic. If you now fix a bug in one of the services, it updates it for all of the client applications immediately. So it's super kind of scalable and robust, this robust thing. So if you're also building a client app to consume that data, now you might have a web application like this. This is the new application we just launched for FlyPDX. And you have some menu data, you have parking status data, you have weather, and you have some flight information. So each one of these is pulled from a separate microservice. It's completely isolated, independent from itself. And if you have something like weather, well, we're getting weather from weather.com and we want to change it to Weather Underground. Now we can change that service to pull from the new area, and our web page and all of our other client applications that are registered to consume that don't have to change a thing. It just works, just updates. So now, when I talk about scalability of architecture, I also want to talk about scalability of our support. We are not spending more than 50% of our time fixing this stuff. We're now doing 5% of our time fixing bugs. And that gives us a lot more time to build cool stuff. That was just up by two.